Welcome to this video on bearings. There are two types of bearings. There's true bearings and compass bearings, but we are just going to focus on compass bearings today. So, compass bearings show the direction from one point to another. The next point's very important. When we're reading a direction, so this line here, we look at our north and south markers first. Is the indicated line closest to north or south? So in this first case, we can see that that line is closest to north. So I write down north. And then I ask myself, from that north point, in what direction, a westerly direction or an easterly direction, has that line or has that point moved? And we can see here it's moved in an easterly direction. How far has it moved? 50 degrees. And this is how we would write the compass bearing of that point. North, 50 degrees east. So starting at north, our line then went 50 degrees in an easterly direction. Let's have a go at this second one. Is the indicated direction closest to north or south? I would say it's still closest to north. So I'm going to write down north. From that northerly direction, where has this line moved? It's moved in a westerly direction. How far in the westerly direction has it moved? 71 degrees. The next one is a little bit trickier. Is this indicated direction here closest to north or south? It's closest to south. And then, in what direction has it moved from that south position? It's actually moved up this way. So it's moved towards the east. How many degrees has it moved? We can use our understanding of this being a right angle to work out what degree is going to be in here. So that degree is going to be 90 minus 49, which is 41 degrees. So we've moved south 41 degrees east. So you'll practice some of these, but hopefully you're getting the idea. So let's have a look at some application questions. This one says a four-wheel drive in outback Australia leaves its current position and travels on a bearing of south 30 degrees west for 156 kilometres. And what we're asked to work out is how far south the four-wheel drive has travelled. Like with trigonometry questions and like with angle of elevation and depression questions, our aim is to draw a picture or a diagram that allows us to then identify a right angled triangle. And then we're going to apply our trigonometry to solve that. So the hardest part about this is drawing our diagram. So let's work through it together. Whenever we talk about a current position, actually that's not a smart place to draw that, we'll draw it over here. Whenever we talk about a current position, we're going to draw up our compass directions. So it's left its current position, which is always at the centre of our compass, and it's travelled south 30 degrees west for 156 kilometres. How far south has the four-wheel drive travelled? So from this point to this point, from this point to this point, how far south? So we can already start to identify where our triangle is going to be. It's going to be here. And there's my right angle. How far south means that I'm going to be trying to find this measurement along here. I always think it's best if we redraw out the triangle so the question becomes more familiar to us. And from here, I can identify or label my sides, opposite, adjacent, hypotenuse. Think about which one I don't need. So I've got my hypotenuse and my adjacent, which are important. Cosine of theta equals adjacent over hypotenuse. And then substituting in what we know, so our angle's 30 degrees. Adjacent is x, what we're trying to find, divided by our hypotenuse. And this is a type 1 question, which means I'm going to take what's on the bottom here and multiply it by both sides to leave me with x. So I'm left with 156 multiplied by cosine of 30 degrees is equal to x. And if I put that into my calculator, I end up with something very close to, I'm going to round to the nearest kilometre, 135 kilometres equals x. So this is how far the four-wheel drive travelled south. That's half the... Sometimes we get questions that have two different directions that whatever we're talking about has moved or travelled. And so in this case, we've got a ship that is travelling due south. So whenever we see the word due, it means directly. Directly south for 3 kilometres and then on a bearing of south 40 degree east for 5 kilometres. And we're asked to find how far east and also how far south the ship is from its starting point. So the first thing is to draw up our compass. Never eat soggy Weet-Bix. Okay, so we've got a ship. It's starting always at the centre of our compass. It's travelling directly south for 3 kilometres, directly south. And then, whenever we change directions, it might not seem it here, but if you have gone on a bearing, whenever they change directions, draw up a new compass. It just helps you to keep track of where you're at. And then on a bearing of south, so south 40 degrees east. 40 degrees east for 5 kilometres. How far east, sorry, let's do A first. How far east is the ship from its starting point? So the starting point's here, and we've gone across to here in an easterly direction. And we can see that this distance to this point is the same as if I took it from here to here. So we can identify that triangle. And this is the hardest part, identifying what you need to actually find. So I'm going to draw that triangle down here. 5 kilometres, 40 degrees. 3 kilometres, and we're trying to, oh, sorry, that's not 3 kilometres. We are trying to find how far east, which is x here. So just be careful, I misplaced that 3 kilometres. That's up here in the different direction. So now go through our steps for solving a trigonometry problem. We've got our opposite, we've got our hypotenuse and our adjacent. We don't need our adjacent in this case, so we're looking at a problem that involves sine. So sine of some angle is going to equal opposite over hypotenuse. So sine of 40, substituting in what we know, equals x over 5. And again, we've got a type 1 problem where we're going to take this denominator, or the bottom half, and multiply it by both sides. And I'm left with 5 sine, or 5 multiplied by sine of 40 is equal to x. And in my calculator, that comes out as x is equal to 3.21 kilometres. Oops, I've gone. That's half of the question. We now need to look at B. How far south is the ship from its starting point? So, if we look at, let me grab another colour. If we look at this, the starting point, how far south? So what we're going to be adding up is this 3 kilometres here, which gave us the distance from here to here. And then we're going to add this value. So if I grab my eraser and erase, oops, where is my eraser? I grab my eraser. I'm going to erase the bits of this triangle that we don't need. Relabel this. Instead of finding how far east, which was this measurement here, I'm now finding this measurement. So I'm going to label that as an unknown x. Well, let's label it y actually, because we labelled this as x. And now I go through the same thing. Opposite, hypotenuse, adjacent, except this time I don't need my O. Instead I need my adjacent. So I'm going to be looking at cosine of theta is equal to adjacent divided by hypotenuse. And then I've got cosine of 40 equals adjacent, my y over hypotenuse is 5, and it's the same process. I'm going to multiply that 5 by both sides, and I end up with 5 times cos 40 equals, I should write degrees in there, equals y, and y is equal to, putting that into my calculator, 3.83 kilometres. So we found how far east the ship was and how far south.